Question 2 from the paper is from paper 1 2018. It was question 4 that year. We're told that the curve with this equation meets the line y equals x when x equals alpha. So what that means is if x equals alpha, we have this situation. Okay, so notice I've replaced x with alpha here, and this would equal alpha because if we want to solve that equation, we can set both the curve and the line equal to each other because y is the subject in both equations. Now, looking at the equation I've just written down in terms of alpha, I can subtract alpha from both sides. So we're going to get 2ln of 8 subtract alpha, and that's going to give me 0. What I can then do is take this left-hand side and call it f alpha, as in a function of alpha. So therefore, if we have f of alpha is equal to 2ln of 8 subtract alpha again, we know that that's going to equal 0. In other words, alpha is the root of that function. And for part A, it says we have to show that alpha lies between 3 and 4. So we're going to look for a change of sign. We're going to test each of those values, and we're going to hopefully generate a change of sign. So let's start with 3. So f of 3 is going to equal, so if you plug 3 into your calculator, I'm just going to drag it over to the other side, so we've got a bit more room. And just clear some of this. So we have 2 multiplied by the natural log. Now, if I do 8 subtract 3, of course, that's going to be 5. And then if I subtract 3 again, we get that. Okay, so I'm just going to plug in the numbers. So we're going to have 2ln of 5 subtract 3, which gives us 0.2188, etc., etc. I'm not rounding that. I'm just going to state what it is. It's only the sign we're interested in, of course. The next value we have to test is 4. If I plug in 4, I'm just going to edit what I've just done. So just moving on to the calculator. So I'm just going to delete that. I'm going to take off 4 instead. And if I do 8 subtract 4 inside the logarithm, that's going to give me 4 there. If I press equals, we get a negative value. So I'm just going to write down what we get. So we get 2ln of 4 subtract 4, which is going to be negative 1.227, etc., etc. Okay. You get a method mark for going through this process. Okay. To finish it off, we have to write down some specific information. So we need to state that, I'll just get rid of my calculator if I can. It'll let me. There we go. No, it's not doing it. Come on. There we go. We need to basically state that we understand what we're doing. So we have a change of sign. Write that down. So we have change of sign. That's the first thing. Okay. Remember that a change of sign shows that for the function to pass from a positive to a negative value between the value 3 and 4, it has to pass through the x-axis. There's no other way it can do it. It could do it if it wasn't continuous. So we also have to state that f of alpha is continuous on the interval 3, 4. Okay, you need both conditions. If it's not continuous, then it can theoretically jump from a positive to a negative, okay, without passing through the x-axis. But in this case, it can't because of the continuity. So therefore, alpha is the root. Okay. Right, so that's part A. Now for part B, you're given an iteration formula, all right? And it tells you to start with x1 equals 4, and then we're going to generate some new values. But you don't actually have to do it on your calculator. We can just show this on the graph itself. So if we start with the input x equals 4, and they very kindly labeled that for you here, and we just read off the graph. So I'm going to just start at that point and go up to the graph. The value you would read off on the y-axis, which would be about here, okay, would be the value of the 2ln8 of 2ln of 8 subtract 4. Okay, that in turn will generate your new input. So to go to your new input, you just need to go across to the line y equals x. And if you read off on the x-axis, your new input would be round about there, somewhere less than 4. Okay, so your new input will then take you to the curve. Okay, that's going to be your new value. That in turn will be your new input. So you go across and then you go down to the curve again, and so on and so on. And you can see that it's going to converge on the intersection point. Okay, so it says in the question, determine whether or not this iteration formula can be used to find an approximation. Well, yes, it can be used. And the reason is because the cobweb diagram, which is what we've just drawn, is spiraling inwards. Okay, that's enough to get you the 2 marks, okay? You have to show it on the diagram. Okay, so you'll get a method mark for showing that, and you would get an accuracy mark for stating that the convergence of the cobweb diagram means that it will work. It's not going to diverge and bounce around. It's going to actually hone in on that route.